Okay, and welcome to another video for Math for Business and Finance and Math Applications. This here is a continuation of Chapter 2, additional set of word problems, doing the odd number problems. And we pick up with, let me get to it here. We pick up with problem 2-59. Okay, this one says, Tamara, Jose, and Milton entered into a partnership that sells men's clothing on the web. And when I read this, immediately my thought was back in the actual word problems in the textbook, there was a problem 2-43 that was very similar. As a matter of fact, it's the exact same as this. So if you want to go back and check that out, check out how I solved that problem in the video. I'm not going to spend much time on this one because I did do that one before, but I'll quickly cover some of the concept here. Right. When I'm first reading this, I'm reading Tamara, Jose, and Milton entered into a partnership that sells men's clothing on the web. So the thing that popped into my head, and I'm going to draw a diagram of it, is that this is the men's clothing partnership that they entered into. And the three of them, all right, the total of the three enters and makes that the whole partnership. So I have Tamara, Jose, and Milton. Okay. Now without reading any more, I don't know what their shares are, what portions they are. But the point I want to get at here is that the men's clothing is equal to 1, okay, or 100%. It all depends upon the problem, whether you're going to use a whole number or percentages, but they basically end up being the same thing. Why? If I have 100%, okay, that's equal to 1. That's the same as 1. Why? Because 75% is equal to 3/4 as a fraction, okay? And the 3/4 is a part of the whole. Okay, so when you're talking about fractions, you're talking about a part of a whole. And if I don't have any whole number in front of the fraction, like if I had 3.5, okay, well, that half is, what I have, 3.5 represents 1, 2, 3 whole numbers, and the half represents a half of the next whole number, okay? That's 1, 2, 3, and the additional half. So fractions are a part of the whole. And when we think about problems like this, we go and we assign the partnership, the table, the pizza pie, whatever it is, and we call that, one whole thing. And that we can represent either by 1 or by 100%, depending upon what the problem is asking. If the problem is speaking in terms of percentages, then we assign the whole as 100%. But in this case here, we're going to be working in fractions, so we're going to say the whole is equal to 1. Okay, I hope you understood that. And again, it's covered, I explain a little bit differently in problem 2.43. Okay, so let's continue on. It says Tamara owns 3/8, okay, and Jose owns 1/4, okay, and what part does Milton own? Well, if Tamara and Jose together, 3/8 plus 1/4, that equals their share, okay, and then we want to take whatever that is and subtract it from 1 in order to find out Milton's share, right? Okay, so that's the thinking. Add these two together, and then we subtract from 1 as the whole, and that gives us Milton's share. So let's do that. Okay, now 3/8 plus 1/4 is how much? Well, since our denominators are different, we have to find a common denominator, and we start with the largest number, which is the 8, because 8 can go into itself one time. Right? Now the question is, can our other denominator go into 8? Well, in this case here, yes, 4 can go into 8. So our denominator is going to be 8. Right? 4 can go in 8 2 times. 2 times the 1 is 2. And then all we need to do now is just add the numerators, and we get 5/8. So we know that Tamara's and Jose's share totals Tamara plus Jose is equal to that 5/8. Now we take the whole 1 and we subtract the 5/8 in order to be able to find out Milton's share, right? Now remember, I had said in another video, any number over itself is equal to 1. So since our denominator is 8, 8 over 8, any number over itself is equal to 1. So we can change the 1 and represent that as 8 over 8. Okay, so our denominators are the same, and now I can subtract the 5 from the 8 and get 3 over 8, and we know that that's Milton's share, 3/8. That's our answer. Okay. Again, look at problem 2-43, and it'll present it. It's the same concepts, but I talk about it in a little different manner. Okay. All right. 2-61. Okay. A trailer carrying supplies for Krispy Kreme from Virginia to New York State will take 3¼ hours. All right. Again, using mental imagery, right, now I'm going to draw it out. If I draw a trip, and I'm going to call this Virginia, and I'm going to say he starts in Virginia, goes to New York, okay, and it takes 3¼ hours to get there, to travel that distance. Now, if a truck traveled 1/5 of the way, okay, so if we're talking about fifths here as our fraction, that means we can divide up this entire trip into fifths. 1, 2, 3, 4, 5. So that's 1/5, 2/5, 3/5, 4/5, 5/5. And it's saying that he traveled the 1/5 of the way. Well, that means I have 4/5 left to go. Right? I could have went and without doing any of this mental imagery, because I know it's fifths, he went 1/5 of the way. Again, we're talking about, here's the whole, and if I somehow magically divided this 1, 2, 3, 4, 5, if I somehow magically divided this into fifths, okay, he traveled 1/5 of the way, and I want to know how much the rest is. Remember, this is a whole of 1. Same concept as the last problem. Okay, just looking at it in a different fashion, that's all. I can start out with saying, since I go fifths, well, 5/5 is 1, okay, remember, as a whole, and I subtract the 1/5, and that means I only have 4/5 left to go. Okay, now, I did this subtraction first for the simple reason it's going to ask me how much longer will the trip take. Well, if the trip is 3¼ hours, and I want to know how much longer the trip takes, well, I have to go 4 more fifths, so I multiply by 4/5. And I'm going to get my answer. Now, I could have done this alternatively by saying, okay, remember we were here by looking at the 4/5, we're trying to say how much of this 3/4, okay, does he have to go? But I could have alternatively looked at it from the perspective of, okay, well, he's already traveled the 1/5 out of the entire 3¼ hours. So I could have said 3¼ times 1/5, and whatever answer that comes up to, then I could subtract that, from the 3¼ hours, and that'll give me the remainder. Okay, so it's just, again, it's just a matter of, if I go and I do this here, and I call this 1/5, I could figure out this 1/5 amount and then subtract it from the whole in order to get all of this. Or, and this is the way I did it, by immediately I said, okay, I only have 4/5 left to go, okay, and that's the amount, because I already subtracted out that 1/5, I only have 4/5 left to go. I can solve for this portion first. It's just mentally looking how you look at it, okay? So Let me erase all of this. Remember, there's always more than one way to do a problem. Okay, now let me erase this too. Give me some space. Okay, so what I have here is I have a mixed number, so I need to turn that into a fraction. Right, so 4 times 3 is 12, plus 1 is 13 over 4, and then that's times 4 over 5. Okay, I can cancel out here. 4 and a 4 goes once, 4 and a 4 goes once, and that leaves me with 13 fifths, because 3 times 1 is 13, 1 times 5 is 5, and since that's an improper fraction, I divide the 5 into 13, and that goes 2 times with 3 remaining. So my answer is 2 3/5 hours longer it'll take for him to do the trip. Okay. Now, if I do it the other way, and I said, okay, I had 3 1/4, right? Again, that's going to equal 13/4, and I multiply it by the 1/5. Okay. Now I have 13 times 1 is 13, 4 times 5 is 20. I need to subtract that from the 3 1/4. I need to subtract it 13/4 minus the 13/20. Now you see how much more difficult this is going to be, because now I need to convert into common denominators. So that's 20, that's 20. 4 and a 20 goes 5 times 3 is 65, and that's 13. And I subtract 13 from 65, and I end up with 52 over 20. And I convert that, and since it's improper, I have to change it back into a mixed number. So 20 and a 52 goes 2, that's 40, giving me a remainder of 12 over 20, and then I have to reduce to the lowest term. So 4 can go in the 12, 4 can go in the 20. That gives me 3, and that gives me 5, and I end up with 3/5. Okay, an alternative way to do it, but notice how much longer and how much more difficult it was for me to figure out the portion here. End up taking figuring out the portion for the 1/5, and then subtracting it from the 3 1/4. The easier mental math was to say, okay, yeah, I have five parts, 5/5, and I subtract the 1/5. All I need to do, which gives me 4/5 remaining. Let me just multiply it by the 3 1/4 and give me my answer of 2 3/5. All right. So I hope that made sense to you. Again, if not, rewatch it again or call and speak with an instructor. All right. Thanks, and see you in the next videos.